Okay, good morning. I've never done one of these silent discos, so I gotta watch my tone. Please put your headset on. Thanks. All right, so can everybody hear me okay? Okay, great. So welcome to day 2 of the summit, first session of the day. My name is Mike Cotton. I'm a senior solutions architect at AWS. Been there for about 4 years. And today we're gonna talk about Active Directory, the importance of it and how it works in AWS. So the first thing I want to start is an agenda. Active Directory in the cloud, kind of demystify what that means, how it's used, what your deployment options are, the use cases around using managed Active Directory, how to choose, trust relationships, and some of the benefits of using managed Active Directory or just running Active Directory on AWS, and then some of the features of managed Active Directory as well. So this is kind of a primer. I think most of you probably already know what Active Directory is, but I do want to cover on a couple of things that make this session pretty important. Non-technically speaking, Active Directory makes up about 95% of the directory services in enterprises today. That's a significant number. And of those enterprises, it makes up about 90 to 95% of all the authentication going on within a directory or within an organization. Again, very significant, right? Technically speaking, what is Active Directory? It's more than just an identity store. It's more than just identities for entities, person entities. It's actually identities for person and non-person entities as well. I can make entitlements decisions on users. I can make entitlements decisions on devices those users log in with. It's pretty important, right? Kind of switching gears, it's not just a directory, it's actually a quasi-management tool, right? Through group policy objects, I can push down policies to Active Directory domain members and get certain types of configuration across my enterprise. It also can be used for light software deployment. You can use group policy objects to pull MSIs down from local repositories and install software on a machine. Really important, right? Active Directory supports directly a number of different protocols. Its primary protocol is Kerberos, but it can, through a derivative process, result in an NTLM. It does support through Radius, MS CHAP, EAP. Through other broker services, it can support SAML, it can support OpenID Connect, it can support methods of OAuth, right? So Active Directory is very powerful, right? And you can see why those 95% of those organizations use Active Directory today. Some of the other things I wanted to cover off with respect to what it can do, it can actually do, from an authentication perspective, it can do authentication on behalf of, or what's commonly called Kerberos constraint delegation. So nothing in this diagram here speaks to cloud. But this next one does, and really what's changed. Well, we got a question mark over on the right-hand side because there's many different ways to deploy Active Directory in the cloud today. But ostensibly, this is the same, you're getting the same results, right? I have Workspaces, which is a VDI solution in AWS that can be domain joined to your domain, to a managed Active Directory. Some of the things we'll get into later today or later this morning. I have applications that can be front-ended by SAML, do Kerberos constraint delegation against Active Directory or not, and get access to those applications either built, customer managed, customer built on EC2, or managed AWS services that you're just using the platform as a service, right? So when you think about Active Directory and your journey to the cloud, I think the far left column is pretty common to most, right? You're doing this today. And over the past 10 years, a lot of virtualization has happened on premises. So you're probably very familiar with virtualizing directory services. So when you start bringing start your journey to the cloud and you start bringing your systems into AWS, we typically call that a rehost or a lift and shift, right? I have capability that's on premises and maybe I need to get off of on premises because I'm closing a data center or I'm end of life with some hardware and I just need to move it off. Instead of making those capital expenditures in on-prem data centers and buying new hardware, I'm gonna move to the cloud and go to this consumption-based model. That's a pretty straightforward process, right? Active Directory in the cloud. EC2 instances running some infrastructure service for you in the cloud. As you move to the refactoring, where you're starting to do native services and native built applications, the one thing I want to draw your attention to is the bottom section here when we're talking about different authentication methods. In no way are we saying that Active Directory is not going to play a role in that. Because quite frankly, I don't see many SAML and OIDC providers today that are true identity sources. They're brokers. They sit in front of something. And if a lot of you guys work in the federal space and you're either a DoD or FedCiv, you're doing CAC and PIV, Active Directory is pretty important there because the derived authentication through Active Directory will take you in and work with SAML for a SAML authentication. And I'll talk more about that a little bit later as well. So from an Active Directory perspective in AWS, Active Directory Pure, there's some things I want to talk about that aren't Active Directory Pure that I'll address in a few seconds here. There's basically 3 different options. And the 3 different options you have are simple AD, which is based on Samba, no trust relationships, no schema extensions, small workloads, maybe an indefinite amount of time, right? And then we have managed Active Directory, which is actually Windows Server 2012, R2. It has a minimum of 2 domain controllers that are installed within your VPC or your region, right? You can add more as you deem necessary. And Managed Active Directory recently became a regional service, right, where you can now deploy Managed Active Directory throughout your region and share it within VPCs within your account or outside of your account. And there's the commonality there is the layer 3, is the routing and the networking. Then you can run Active Directory on EC2. What does that mean? I could build an Active Directory standalone, I could build an Active Directory with a trust relationship, or I could build another domain controller for an existing domain and just extend it into the cloud. This last option here is really the kind of the first approach when we talk about what your options are. And stop reading the screen for a second and just look at this as the same way you look at Active Directory today. You probably have a diverse population of users, geographically dispersed that is, and you don't have domain controllers everywhere. And you probably have a decision-making process in your environment today to determine where and when you want to put a domain controller. That's what this is. This is running Active Directory in your network with a direct connect or a VPN direct connect or a VPN over the internet, basically extending your network into an AWS VPC and doing authentication long haul. And this is what it looks like, right? So don't think of this as AWS, think of this as just another network in your environment. Could be a remote field office, could be an up and coming regional office. And maybe I haven't had the time to buy domain controllers because in the old way of buying them, it takes months in the federal government. So let's just do this for now. So this is the same concept with AWS. Maybe you're starting off, maybe you're doing some dev tests, you don't have a need for domain controllers in AWS. Let's set up the network connection. Let's do some long haul stuff. Some of the things you want to key on here are the DHCP options within your VPC, pointing to the right domain controllers and the domain suffix. And then the next option is bringing EC2 into your AWS environment, right? And again, some of the things I talked about before, DNS, sites and services. You're building this. This is your responsibility to set up, make sure DHCP is right, make sure you're extending your sites and services. And then you're responsible for creating a highly available environment. Now, one would argue that more than one domain controller in Active Directory is highly available, right? You do have to account for the FSMA roles and making sure that they're all moved around and accounted for in the event of retiring servers, but that's stuff you do today. And we make things a lot easier from a backup and restore and locking down the security of a domain controller within AWS. So while this is a lot more words here from a responsibility perspective, it's really not a lot of work, okay? And again, it's really no different than what we had before in the first option, except now we have domain controllers in your VPC. So the same things you did around configuring the DHCP options on that VPC to point to the DNS servers and the domain suffix, you just change them to point to the domain controllers now that sit in AWS. Create yourself a site and sites and services so all the authentication stays local. Pretty straightforward. Anybody I know we can't take any questions during this, and I'll be outside where it says meet the speaker for as long as I need to be. But just kind of shake your head yes or no. Everybody understands what I'm talking about here? All right, cool. And then the other option is managed Active Directory, right? And I'm going to spend some time talking about what it is and what it isn't in a little bit. But essentially, what it is it's Windows Server 2012. It's Active Directory. We spin it up for you. It's about 3 or 4 clicks. You can add domain controllers to subnets in your VPC as you need to. But we manage the backups, we manage the patching of it, we manage the restoring of it. All you do is administer it through Active Directory users and computers, right? And again, we'll get a bit more into that. So what is a managed Active Directory? I think I covered a lot of this stuff already. Seamless domain join, RDS for SQL, it's a requirement, right? So we do have 2 other options for connecting your Active Directory, sort of like cross connects. One of those is Active Directory Connector, and you'll see me pepper that out throughout the presentation as we go through this. Active Directory Connector doesn't work with relational database services, RDS, Microsoft SQL. Microsoft SQL RDS with Windows authentication requires managed Active Directory, right? Okay. Some constraints, we're the admins, domain admins. We give you OU admin rights. We like to say it's a relatively conservative delegation model, but as of today, I think it's 18 or 19 actual delegations that we provide to you. So if you're thinking about synchronization, replication of directory permissions, if you're thinking about certificate services, we give you delegated rights to install that. Thinking about DFS, distributed file service naming service, right? We give you permissions for that. We give you account operator. There's a number of different delegations within Managed Active Directory that will let you do the jobs that you're required to do. We also allow the extension of the schema in Managed Active Directory, but we don't do it through a delegation. We actually do it through the console. When you go into the console and you're managing your Active Directory, your Managed Active Directory, there's a place in there where you can actually, there's a place where you can do all kinds of maintenance on your Active Directory, snapshots, restores, set up notifications to get statuses on your Active Directory using SNS services, emails and text. But there's actually a place in there where you can drop an LDIF file. And we will go through and validate the LDIF file. And if there's an error in your LDIF file, we will actually surface the error message that comes from the LDIF import. So you could do schema extensions on your Active Directory, and it happens relatively quickly, right? It's an automated process. One of the things I didn't talk about was the GPOs, right? We delegate permissions to creator-owner GPOs on your OU and the nested OUs within that. Make sense? All right, so the options again are, pay close attention to these because we kind of double up down near the bottom. But it's no domain controllers in AWS, just basically extending the network and doing a long haul authentication. Bring your domain controllers into AWS on EC2 and do some replication. You can bring your own new domain if you wanted to, build it on EC2 and do one-way, two-way trust, synchronizations. You could do Managed Active Directory, one-way, two-way trust, and we'll talk a bit more about what's supported and what's not supported from a Managed Active Directory perspective. The bottom one here is pretty interesting, right? And I'll talk a bit more about how we do that and what the patterns around that are. But think of Azure AD Connect and the pass-through authentication, the password sync, or just a synchronization for SAML support. We now, because of some of the directory permissions or the delegations that we do in Managed Active Directory, we now allow you to install an ADFS server, and we allow you to install an Active Directory, an Azure AD Connect server. So you can actually sync to Azure and make that your point of authentication for Office 365. Skype for Business, email, SharePoint Online, and all that stuff. Now, what we're saying down here is that could be from your Active Directory running on EC2, or that could be from a managed Active Directory that we manage for you. All right, so let's get a bit deeper into managed Active Directory. This should be common to most people with respect to what Active Directory domain join provides you. Some of the things I covered earlier. But when you do managed Active Directory in AWS, there's no additional steps in order to enable that Active Directory to be leveraged by AWS services. The list of services at the top: RDS for MS SQL, the Work Star products, Spaces, Docs, and Mail, QuickSight, Chime, and Connect. Now, you need to go into the managed Active Directory console, enable these. They're not all just enabled, but once you enable them, then there are services that can be used or that can leverage your managed Active Directory. Make sense? Now here's where it gets interesting. I'm going to spend a few minutes on this one here. So what you don't see here is you don't see an Active Directory that you manage, that you built, that you brought into AWS. That's AWS Managed Active Directory. And because of the delegated permissions that we provide you, you can install ADFS. You can do the schema extensions on ADFS, which require those for device authentication. You can install an Azure AD Connect, and you could do synchronization with Azure AD, your Office 365 tenant, and you can set up SAML authentication with Office 365, and that list is just a subset. And those are mostly SaaS providers. I'm thinking of there's other applications internal to your organization that can use SAML as well, like Oracle with WebLogic, pluggable authentication modules in Apache and stuff like that. So that's a pretty powerful approach, right? We take it a little bit further here in the next step. Customers have always asked us, how do we get away from having to manage ADFS? So ADFS can be a bit challenging to manage when it comes to making sure your certs are valid, making sure all your claim rules are valid. So what we're doing here now is basically the same thing. We're syncing to Azure or any of these other services that require a sync, which most of them don't, but Azure does for Office 365. Basically what you're doing in Office 365 is you're creating a placeholder for a mailbox, which is attributes on a user object in Active Directory, or in that case, Azure Active Directory. So that sync is required for that mailbox, not necessarily for SharePoint or Skype. Anyway, so what we're doing now is we're saying you don't need to use a customer managed Active Directory Federation server. You could actually use AWS SSO or single sign-on. Again, this is another one of the things I said that really isn't Active Directory, but it's a service that uses Active Directory. So single sign-on is so when you think, so let's kind of take a pause for a second. When you think of SAML authentication, there's a number of different things that come to mind for me, right? And that is how do I set up trust relationships, whether it's with another SAML service, another security token service, or with an application. And typically what you're seeing is if you're doing STS chaining, SAML to SAML, then both of them need to be able to consume a SAML token with assertions in it. And AWS SSO at this time does not, right? It sources its identities and its authentication from AD, right? So you have the Active Directory connector or the managed Active Directory as part of the back end of AWS SSO, but it actually produces a SAML output that can be consumed again by, if you guys have access to the console, go in and look at it. There's probably close to 75 different canned applications that are all ready to go with AWS SSO. So this is kind of a unique thing, right? So instead of managing your own ADFS server in AWS, I mean, you can if you want to, but a lot of companies and organizations have been asking us to say, well, we really want to get away from that, want to get away from what we call the undifferentiated heavy lifting. And with this pattern right here, we're allowing you to sync for purposes of Office 365, and we're allowing you to use AWS SSO as that interaction from a SAML auth perspective with Office 365. And I've actually done this, so. All right, it gets a little bit more interesting. There we go. So what we're doing here is we're saying, okay, well, our users don't sit in Managed Active Directory. Our users actually sit maybe in my existing Active Directory. So what I'm going to do here is I'm going to set up a two-way trust relationship with Managed Active Directory, still do my sync to Azure from my existing Active Directory, but use the pass-through authentication with Managed Active Directory to leverage AWS SSO to get the same results. I thought that would get an applause. I'm kidding, guys. All right, so now, so I'm gonna slow down a bit and just give you guys a chance to chew on what we just talked about. At this point in normal presentations, I would actually see if there were any questions, but I've been admonished not to do that. So, all right. So deployment differences between Managed Active Directory and an Active Directory running on EC2 that you manage. It's pretty self-explanatory. I covered a lot of this earlier. You manage it, you design for high availability, and when you set up trust relationships, you have to open up the firewall rules, the ports and protocols. They're a very limited set for trust relationships. We're much greater for domain joined. But from an AWS perspective, you're not a domain admin. You basically have OU admin rights and then 18 or 19 delegated permissions that I alluded to earlier. Some reasons why you wouldn't want to use Managed Active Directory, or guess you could look at it either way. Some reasons why you'd want to. I kind of focus on what am I not getting. So if you needed Active Directory services that were outside the region, and again, I haven't started talking about how that works. That's a little bit later. If you needed Active Directory services that were multi-region, then Managed Active Directory probably wouldn't be a good fit for you because there's really no way to be able to do that today in AWS, where you would do that with Active Directory on EC2 is basically layer 3 and DNS and firewall rules. If you need NetBIOS name resolution, it's 2019. I hope there's not a lot of that out there. I know that SQL required it just a few years ago, but I think that's been deprecated or removed. Require permissions not yet delegated by AWS. And again, there is a list of them that you can go look at. It's well documented on our AWS docs. I'd be surprised if there's some applications obviously that jump out at me, and I have these examples down here. But I'd be surprised if most situations you can't use Managed Active Directory because the delegation is pretty powerful. But then you have systems like or applications like Skype for Business is another one I was thinking of. But Exchange, for anybody that's ever run an Exchange server, it writes all over. It does schema extensions, the domain naming context, the configuration context. Certificate services do that, but we've delegated that right to you. There's DNS, or not DNS, but yeah, DNS and DHCP, do that as well. But there's no DHCP required because the VPC takes care of that, and we manage the DNS side of it. But when you start thinking about applications that actually write to various different partitions in Active Directory, that's probably where you're going to run into challenges. The schema, you could do schema extensions, but Exchange and Skype for Business, those are a bit more difficult to implement. So there may be reasons why you wouldn't want to use a Managed Active Directory for those types of implementations. Okay. Deployment differences, SSO to the cloud, again, all of those will support it with the AD connector. It's native with Managed Active Directory, but with AD connector, it does support it. We do seamless domain joins again, not without the AD connector, although there are ways around it using the user data of an EC2 launch to put your own PowerShell script in there, provided that your DHCP options in your VPC are pointing to your domain. Domain controller configuration, again, this is the managed versus unmanaged. It's pretty high. Maintenance is incremental maintenance is marginal. AWS is pretty good with respect to automation around your EC2 instance, right? Automating snapshots and stuff like that. So the maintenance is pretty low. And we also, don't forget, we can also do encrypted EBS volumes. So when we talking about, BitLocker versus, you can do encrypted EBS volumes as well. The incremental system, again, it's a little bit higher here. It's not as high as provisioning a physical server and having to install and join it to a domain or find a place for it in the rack. But you still have to go through the process of provisioning it. You could probably script that pretty well, but it's still an effort. Adding new systems to manage Active Directory is literally going in and say, adding a new domain controller, pick a VPC, 15 minutes later it's up, right? Incremental entitlements, I think that's kind of a wash. And then obviously down here, we give you access to sites and services to rename the site, but the IP address additions to that are our responsibility. And then the other thing you want to consider too, and this is really not an AWS thing, but if you are doing a trust relationship between two Active Directory forests, you could overlap the site names, right? Like, I don't know, DC1, and the two different forests, and you will get site coverage across that trust relationship. But that's not something that's really straightforward, so we kind of stay away from that. All right, let's pause a second. Everybody okay? All right. Everybody still can hear me fine? Great. All right, so this is kind of just a real quick primer. Trust relationships are in the opposite direction of access, right? So the old analogy is you're leaving town, you run across the street to your neighbor's house, give him a key, say, can you come feed my cat? My arrow of trust is to him, his arrow of access is to me. That's all we're saying here. Now, giving him a key to my house means he has access to my house. A trust relationship doesn't necessarily mean that you have access. There's still an entitlements process that you have to go through. So, there's some rules, some best practices that we've developed or we believe are strong best practices that we kind of want to go through here. But before we do that, I want to go through the trust models that are supported. So, on the left-hand side, you have a managed Active Directory. And on the right-hand side, you may have a prototypical forest with a separate tree root domain. And basically all that is namespace changing. So a forest, so kind of inside baseball here, Active Directory is highly dependent on DNS. The DNS is very important to Active Directory. 90% of the errors that you're going to find, 85% of the errors you're going to find in Active Directory are going to be DNS related or network related. So in this case, we have a forest that has a namespace of example.com, but it has a tree sprout off to the side, off to the right, what we call a tree root domain called companyfoo.com. The problem with this is namespace, name suffix routing. Although you can do alternative user principal name suffixes within managed Active Directory, it's difficult for us to surface that through name suffix routing. And if you guys are familiar with doing forest trust, each forest trust will have a name suffix routing table or not. It'll be the default example.com or you can edit it. And my friends here in the front know exactly what I'm talking about. And right now we do not support name suffix routing or name suffix exposure for that tree root domain. So Managed Active Directory supports a forest trust with a single root and a contiguous namespace. I'll say it again, single root, contiguous namespace. Now, this trust relationship will work here, but users in xcompanyfoo.com or the root won't get authenticated. So there's a way around that, right? Managed Active Directory supports both forest trust, two-way, one-way, and domain trust, two-way, one-way, or what some people call external trusts, right? So this is one example. Remember, these trusts are not transitive. That means that if I want to trust somebody in hrexample.com, I've got to have a trust with them. A forest trust is transitive. I could trust the forest root and get that transitive authentication all the way down within that tree, or within that tree. Domain trusts or external trusts are not transitive. So when you have a lot of times people call these shortcut trusts too, but shortcut trusts are typically inside a domain or a forest, not a cross forest. But anyways, when you do these types of trust relationship, you're only trusting that domain. So in this case, I guess it would be, I'm trusting the father figure of the house that I gave the key to, not his kids and his wife, if that works. Here's another way to do it, right? I could do a forest trust with the single tree, example.com, and a domain trust either at the root level, the tree root level, or at the tree child domain. All right, so I'm just gonna do this real quick again, because this is pretty important. All right, so today we support one-way, two-way forest trusts. We're just talking about forest now, with a contiguous namespace forest, no trees. Name suffix routing we can't expose that today. And name suffix routing basically says I've got a conditional forwarder in DNS, I've got a name suffix in my name suffix routing table, they both equal example.com. What happens when I ask for companyfoo.com? It doesn't know where to go. So the alternative is one or two-way domain trust with all the domains that you want to trust, or in this case, a two-way forest trust, or a one-way forest trust, and a two-way or a one-way domain trust. Okay, right. So now that we've talked about trusts, here's some things that you want to do. So I don't know if everybody knows what SID filtering is. I'll be outside, and I will take your questions outside if you have them on that. But maybe this will help. SID filtering rejects the assignment of a SID in an access token or as part of a user and that access token across the trust relationship that isn't owned by the origin of that trust. Meaning that I'm B, you're A. Sorry, can you hear me still? I'm B, you're A, and I have a SID from your domain associated with my user ID, and I log in across the trust relationship. If SID filtering is turned on, that SID's stripped out. Now, the reason why you would want to turn SID filtering off is because if you do migrations, right? Migration SID history, I'm going from domain A to domain B, I'm moving my file servers and stuff like that over. They're already ACLed with my SID. If I move them over to you, I've got to re-ACL them all. That's a process I go through. But with SID history, I don't have to. I can just move them over, re-ACL them later, and still have access to my systems. And that's where the SID history comes into play. SID filtering is enabled by default. Another word of caution too is, just by a show of hands, how many people have heard of lateral credential theft and pass the hash? Right. SID filtering needs to stay on. Right. Now it's not going to protect both of those. Lateral credential theft, you know, it's basically grabbing the cache credentials and walking through them to find elevated credentials and then using them to walk around the environment. But this is another mitigation step. Selective authentication, opposed to forest-wide or domain-wide authentication, is basically selecting users or groups of users that can authenticate across the trust. If you do forest-wide, anybody can. If you do selective, only the people you select. The second step to that process is actually going to the resource and granting permissions on the resource as well. So, you know, domain B, selected users can authenticate across the trust relationship. That happens to be a group called selective authenticated users. You need to select it there, and you need to go to the actual server, the resource on that server, and say, this group of people can log in here. So it's a two-step process, opposed to it's just wide open with domain-wide or forest-wide. So this gets a little bit more complex. It's not a hard topic. When I talk about trust ports and stuff like that, it's not a hard topic. There's things like port pinning. There's a bunch of different lower order ports and ephemeral ports that you need to consider. And if you guys want to, and I kept the links in the presentation here right to those locations that actually tell you exactly what you need to do. And it'll talk about port pinning and all that stuff. But if you want a bit more explanation, I'll be outside and we can talk about this one here. But again, a trust relationship requires less ports and protocols open between trusting providers or trusting identities or trusting sources. Domain join requires a lot more. And something else to be careful about too is that Kerberos is a client referral protocol, whereas NTLM is not. If I want to access a server, whatever it may be, a web server, a file server, whatever, and it doesn't support Kerberos, it'll fall down to NTLM. I'll give him my NTLM token and he'll go validate it. He'll go validate with his authority, which happens to be a domain controller. In Kerberos, it's completely different. I try to go to a resource and they negotiate Kerberos and it will say, go get a ticket. So he's got to walk the tree, go to his local domain controller, do a global catalog lookup. If it's a forest with a forest trust, it walks up to the root, jumps across the root, then down to the child. So when you start thinking about these types of trust relationships, you start thinking about opening ports, it's not just between server A and server B, it's between all the servers in one domain and all the servers in another domain, and the clients need to be able to make that referral themselves. If a client cannot make the referral, your only option is to fall back to NTLM, but that's not a decision at that time. If it cannot make the referral, the client authentication fails. The decision is made at the point of negotiation. When somebody establishes a session or attempts to establish a session with a server, a web server, it's going to go, all the conditions are right for Kerberos. Yeah, they are. Let's do Kerberos. And if Kerberos fails, authentication fails. It's only when they negotiate to NTLM that will do NTLM. So it's a pretty strict process by which authentication works or doesn't work. Anyways, again, if you need more information on that, I can talk to you after this session. And then this last one's pretty straightforward. I would say that this is the same thing you do in any trusting environment or lack of trusting environment. Don't grant groups in the cloud access to on-prem resources. Okay? Duh. All right. So for you guys, security conscious folks, Managed Active Directory allows you to actually stream your security event logs into CloudWatch. Existing logs or new logs that you create yourself. This is pretty important because you can create your own metrics against that and get SNS notifications, take automated actions or whatever, right? It's pretty straightforward. You just go in and say enable forwarding to CloudWatch, and it basically asks you, do you want to create a new log group or do you have an existing one you want to point it to? And those logs will start streaming there. Now, the interesting thing here is with CloudWatch log agents, I can do this on any EC2 instance and more. So, one of the benefits of Managed Active Directory, it's a pretty simple point and click. When you're running Active Directory on EC2, and quite frankly anything on EC2, and you install the CloudWatch log agent, you can ship those logs, not just the security logs, all the logs, to CloudWatch. So CloudWatch is really great for looking at the perimeter of your device, EBS volumes, CPU utilization, and stuff like that. But if you want to look into your system, you're either doing it with applications and products that you have, or you're installing a log agent on there to be able to do that and expose all those events in CloudWatch logs. And if you're familiar with CloudWatch logs, you create your custom metrics there for either alerting or alerting plus automated action. Okay? Okay, so directory sharing. Pretty straightforward here. Create a Managed Active Directory, and I go share it with another account. What does that look like? So today, if I have a Managed Active Directory in an account, I can expose workspaces, work mail, work docs, EC2 joins, RDS for SQL, and then and the reason why we're breaking this down into VPC and outside the VPC is because some of these are installed in your VPC, right? Dropping elastic network interfaces or ENIs in your VPC. The other ones are not installed in your VPC. They're publicly accessible, but they can leverage the API calls to your Managed Active Directory. So this is prior to directory sharing, this is the way it worked. So with directory sharing, I now can, again, and they're using peering here. You can use any kind of connectivity method you want. But I would like to take a second and plug a new service, Transit Gateway. Are you guys familiar with that? That's full-on layer 3, 50 gig ENIs. It's pretty powerful. Peering connections do not allow transitive connections, right? So if you had 3 VPCs, A, B, and C, A could talk to B, B could talk to C, but C couldn't talk to A through B with a peering connection. But with Transit Gateway, it's full layer 3 routing, BGP, and more protocols coming. Anyways, so this is a peering connection. The point we're making is, got to have some connectivity. So what happens? We now expose those domain controller API calls to the other account, right? Today it's EC2 and EC2 only. If I was a betting man, I would bet that before too long we would see RDS and those other services on the right-hand side as well. Okay, so just kind of a recap here. Sharing model. Is everybody familiar with AWS organizations? So if you're trying to share your Active Directory, your managed Active Directory with another account that's in your organization, no handshake required, it just shows up. If you're trying to share your managed Active Directory outside your organization, there's a negotiation. I go, here, I want to share you, do you accept? Yes, I do, and all that jazz goes on. And then charges to the account which directory is shared, right? So shared with. And then again, back to the prerequisite here from a network perspective that you just have to have routes to it. All right, so that's it. Thank you.